Let's now talk about control objectives and what exactly are controls. Now, controls are tactics or strategies that proactively minimize risk by reducing or eliminating either a vulnerability, the likelihood that a threat actor will exploit a vulnerability, or the impact of an exploit. So when you think of controls, you think of things like, say, firewalls, anti-malware, security awareness training, security policy, security guard, and so on. Basically anything that can reduce the likelihood of us getting attacked or hacked by cyber criminals, that would be a control. We're going to talk about the control categories and so on a bit later. So in addition to controls, we do have something known as the countermeasures. These are controls implemented to address a specific threat. So controls are more broad in that they combat a variety of threats together, but a countermeasure is aimed at combating a very specific kind of threat. So countermeasures are generally reactive. Controls in general are more proactive, but a countermeasure is more reactive. Countermeasures are typically employed when a company has been hacked, when there's a security breach. So the company might decide, you know what, to make sure that this particular kind of breach never exists again in the future, we're going to deploy this particular countermeasure against that specific kind of threat. So like I said earlier, they are more effective, but less broadly efficient. So yes, they're very effective at combating a particular kind of threat, but then don't really do a good job of combating other types of threats. So controls in general should be verifiable. They should be trustworthy. These should be controls that we know that will get the job done. And then we can also describe a control based on a variety of factors, such as like the functionality. What exactly will this control do for us? And then the effectiveness. How well will a control work? And we're talking about the consistency, reliability, and then can the control actually do its job in a timely fashion? And then assurance. This is the measure of confidence that intended security controls are effective in their application. And then finally, cost benefit. What I mean here is that a control needs to provide a benefit that would far outweigh the cost of actually implementing that control. If you were to look at risk management, there's actually the concept of risk acceptance, where a company knows that, you know what, we're using this application, we're working with this kind of data, there is a vulnerability, there's a risk involved in this. And then rather than them eliminating that risk, they say, you know what, the cost of us actually eliminating this risk is going to far outweigh the negative impact if this risk was actually exploited. So in those kind of scenarios, the company will just say, you know what, whatever, we'll accept the risk. So before a control can actually be bought or used, it needs to provide a lot more of a benefit than the actual cost of that control for the company. So this brings us back to the main topic right now, the control objective. What exactly is a control objective? So this is a statement of a desired result that should be achieved by implementing a control or a set of controls. So as an example, we do have the control objective. We want to improve general cybersecurity in our company. We do have a variety of controls that can do that, like security awareness training, security policy, and then of course upgrading your firewalls, anti-malware, and so on. Now, regarding control objectives, we do have this concept of defense in depth. We're going to talk about this a bit later on in the course as well, but then defense in depth is the design and implementation of multiple overlapping layers of diverse controls. So basically you can have like layer 1, layer 2, layer 3. The whole point here is that if an attacker was able to bypass layer 1, then there'll be layer 2. They bypass layer 2, there's layer 3. It's kind of like a video game, right? So you have all these different layers that the cyber criminal will have to get through before they're actually successful in their attack. Now, there are two main properties of defense in depth. One is that the controls involved should maintain independence and not be subject to a cascade effect. If you're wondering what exactly a cascade effect is, think of a pack of dominoes. You have all these dominoes lined up against one another. If the very first one falls, the first domino will fall on the second one, it falls on the third one, the fourth one, fifth one, and then all of them collapse. That's the whole point here. the way the defense in depth is configured, it should make sure that, okay, if the first security control is defeated, that shouldn't lead to the defeat of the second control and so on. They should maintain independence of one another. And then the diversity of controls should be considered. When we talk about diversity of controls, we're not just talking about the functionality of the controls, but also the vendors of those controls. You don't buy all your controls from one specific vendor because, yes, the vendor might be very, very good in a particular kind of control. Maybe they produce very, very good anti-malware. But when it comes to firewalls, maybe there's another vendor out there that actually makes better firewalls. So diversity of controls regarding the functionality and the vendor should be considered. And then we have the security control baselines. These express the minimum standards for a given environment. So they should serve as a starting point and then should be proportionate to the criticality and sensitivity classifications of the asset being protected. The principle of proportionality. The whole point here is that if you have data that's not that important, that is not that sensitive, then the amount of controls designated to that particular kind of data should be at a minimum. Why spend so much on data that isn't critical? But then if you have data that's very, very important, that's critical, then yes, you do want to spend as much money as is needed to ensure that that data is kept secure. Now, you do have the fine-tuning controls for your security control baselines. You do have the concept of scoping. By the way, a control baseline, you do have certain bodies and organizations like the NIST that have come up with their own control baselines. Okay, so you want to improve authentication. Well, here's the baseline of controls that you need for such. So the thing is, these baselines, these pre-configured manuals of security and all that, they may not always be applicable to every kind of situation. So if you, as the security architect, you are taking that baseline, you want to fine-tune that baseline into something that will fit your particular scenario perfectly. So we do have the controls in here. We have scoping. Scoping means you're eliminating any unnecessary baseline recommendations that are not applicable. Okay. And then you have tailoring. Tailoring is now you customizing the actual recommendations in the baseline to align with your objective. So note the difference. Scoping is you're completely removing. Tailoring is you're not removing, you're simply editing, you're simply fine-tuning. And then we have compensating, where you're going to substitute a recommended baseline control with a similar control. Now, this can be because of budget. Okay, maybe your company doesn't have enough money to actually go with the recommended control in the baseline. So you're going to go with a similar control that's maybe just as effective, but a bit more affordable. And then supplementing. Okay, so you want to add to the baseline recommendations. Again, these baseline recommendations, they don't fit into every particular kind of scenario. So maybe in your particular scenario, you may need additional controls as well. That's where the supplementing comes into play. So this is basically the baseline modification process, okay? The first right now is you identify the control baseline you're going with, and then you're going to apply scoping. You remove whatever isn't needed, and then you're going to modify whatever controls are left. And then if needed, you might apply compensating controls. And then if needed, you might also supplement the baseline. Once that's out of the way, you can then publish. Okay, you're going to publish the configuration, and then you implement the configuration onto the network, and then you assess the performance. Okay, how well is this control actually working? If you still need to make some changes, then you can go back, repeat the entire process. But if it's doing its job very, very well and good, okay, fine, keep it up. But then you want to keep on monitoring to make sure that the control is just as effective as it was in the very beginning. So that's it basically for this particular topic. Thank you so much for watching the video. I will see you in the next class.